Hi friends, in this video we will see the associativity and distributivity. There are two different properties of fuzzy sets. So let us look into these fuzzy sets. So how these things will be hold good for fuzzy sets also. Okay, first let me write. Let me take three fuzzy sets here. Three fuzzy sets. So the fuzzy sets are like this: A, A. So this is its value is 0.5 divided by 1 plus 0.25 divided by 1.5 plus 0 divided by 2 plus 0.25 divided by 2.5 plus 0.5 divided by 3, and B. So B is given as 1 by 1.0 plus 0.65 by 1.5 plus 0.4 by 2 plus 0.35 by 2.5 plus 0 by 3. Next we will see the C. So C is like this: 0 by 1.0 plus 0.25 by 1.5 plus 0.6 by 2 plus 0.25 by 2.5 plus 1 by 3. So these are the values. Yeah, the values are all correct. Yes. Now our job is to find associativity and distributivity. So first we should know what is meant by associativity and prove. Here we need to prove associativity, and distributivity. So these are the two things we need to prove. So let me go ahead with the first one. Associativity. So what does it mean by associativity? So associativity means, so there are two things in associativity. So the first thing is A union of B union C is equal to A union B union C. So this is one associative property. And the second associative property is A intersection of B intersection C is equal to A intersection of B intersection of C. So these two are the associative properties. Next, coming to distributivity, even in distributivity also we have two things. Distributivity, so distributivity means A union B intersection C is equal to A union B intersection A union C. Similarly, A intersection B union C is equal to A intersection B union A intersection C. Yeah. So these are the two things we need to prove now. So these are the two things. Let's go ahead with one by one. Okay, first we will see associative property, and let me write these things as some number. I like to give some numbers for this. So let me give one number here. This is 1, and let me give it for 2. This is 3, and this is 4. So practically, to prove associativity, either 1 or 2 can be proved, but in this problem we will prove both of them. And coming to distributivity also, we can prove any one of them, but in this problem we will prove both of them. Okay, so let's start with this, and we will move forward. Yes, let's open a new page. Yeah, let's go there. Hmm. Yes, so here we can solve the things, but we should have the, yeah, before going to that we need to first, let me solve first problem. Maybe first problem, associative property. So the property is A union B union C is equal to A union B union C. So in this we need to find, first we need to find one thing. Here we need to find B union C first. So to find B union C, I should have the membership value of B union C is equal to B membership value of B of X. Of course it should be X for one particular value, B of X or C of X. So this is the formula. So we need to follow this formula because this is the basis for this. So in this way we need to follow. Okay, first B union C of X is equal to B of X or C of X. That means here what we need to do, we need to see the maximum of these two. We need to find the maximum of these two. So union means it's the maximum. So I can write the same thing. It should be the maximum of mu B of X, comma mu C of X. Okay, of course, the cannot go back, but still we can bring those things here. Okay, let me see here. Otherwise, let me write here. Not an issue. I like to write all the three things here also. A equal to 0.5 by 1 plus 0.25 by 1.5 plus 0 by 2 plus 0.25 by 2.5 plus 0.5 by 3. And similarly, B is equal to 1 by 1 plus 0.65 by 1.5 plus 0.4 by 2 plus 0.35 by 2.5 plus 0 by 3. So C is equal to 0 by 1.0 plus 0.25 by 1.5 plus 0.6 by 2 plus 0.25 by 2.5 plus 1 by 3. So these are the three values here, and we need to find now. So let's move further. Yes, so I can easily find B union C, which is equal to, according to this formula only, maximum of B of x, mu B of x and mu C of x. So this part is called mu. As we know, the whole part can be represented as mu of x divided by x. So now the x is the below value, the denominator is the x and numerator is mu of x. Okay, now this is B. So mu B of x means, let me take x as 1.0, then mu B of 1.0 is 1. Similarly, mu B of 1.5 is 0.65. Okay, in that way we need to identify the things. So now let's go ahead. If x is 1, what is mu B of x is 1, and if mu C of 1 is 0. So 1 and 0. So what is maximum of 1 and 0? Obviously 1. So this value will be like this. So please try to understand. I will explain you once again for value 1.5. Okay, for 1.5, mu B of 1.5 value is 0.65 and mu C of 1.5 is 0.25. But I need to find the maximum out of these two. So that will be 0.65 by 1.5 plus similarly 0.4 and 0.6. The maximum is 0.6 by 2 and 0.35 and 0.25. The maximum is 0.35 divided by 2.5 plus 0 and 1. The maximum is 1. 1.0. That's all. So this is B union C. Okay. Sorry. Yeah. This is B union C. Now let's see what is A union of B union C. Let me write the direct value, as this is B union C and this is A. I can compare these two. Okay, so yes, this is also union, so I need to find the maximum out of them. So here for x equal to 1, the value of B union C is 1 and A is 0.5. So the maximum value is 1. So let me write directly 1, and 0.65 and 0.25 is 0.65. 0.6 and 0, so it is 0.6. 0.35 and 0.25, so it is 0.35. Next 1 and 0.5, it is 1. That's also, this is A union B union C. Okay, it's very simple concept. Now let's move on to the so one part is over now, so this part is completed. Now we need to find this part. Okay, on the same lines we need to find A union B. So let me write A union B here. Yeah, please let me change the color, maybe some other color. Yeah, let me continue with pink color. Yes, so this part is up to this, it's okay. Now I need to find A union B. So A union B is equal to, let me go back just up and I will see what is the value. Yes, so maximum of 1 and 0.5 is 1, so it will be 1 by 1.0 plus, next maximum of 0.25 and 0.65 is 0.65, 1.5 plus 0 and 0.4, it's 0.4 plus, and 0.25 and 0.35, it's 0.35 plus 0 and 0.5, it's 0.5. Yeah, so I can conclude that this is A union B. Now what I need to do, I need to make it A union B union C, which is equal to, so this is A union B and this is C, so maximum of 0 and 1 is 1 plus maximum of 0.65 and 0.25 is 0.65. So maximum of 0.4 and 0.6 is 0.6. Similarly, maximum of 0.35 and 0.25 is 0.35. And maximum of 0.5 and 1 is 1. If you can clearly see here, and this part and this part are same. Okay, you can see. Yeah. You can clearly see here, this part and this part are same. So hence, associative property is proved. Hence, associativity is proved. Right? See, for 1 it is 1, for 1.5 it is 0.65, and for 2 its value is 0.6, for 2.5 its value is 0.35, and for 3 its value is 1. Okay, so simply I can say that A union of B union C is equal to A union B union C. Okay, simple. So this is the associative property, and we have solved the first problem. Now let's go to associative property only, but now we are dealing with intersection. Okay,